Okay, there's a lot of problems here. Many of them we went over in class, so I'm going to try to focus on the ones that we didn't go over. And I'm going to go relatively quickly because there are so many problems, but that's the beauty of a video. Just don't forget, you can pause, you can stop, you can go back, listen to it again. So, and many of these things we've talked about in detail in class. So this isn't designed for you to get this if you were cold, if you didn't know anything about this, okay? All right. Remember, for these, we're going to state the postulate or theorem. And that's all they want. They don't want to name it. Obviously, there's no letters here, so we don't have to do that. So remember our two freebies. This is the reflexive property when two triangles share a side. And these are vertical angles. Those are our two freebies. You have to know them. I am mixing notation here. You know, see how they mark angles congruent in problem 2. So maybe I'll change that. But you should be able to go back and forth between both notations, which are both commonly used. All right, there. Now I've matched their notation. Okay. So the first one, though, we have ASS, right? ASS. And normally we would say, oh, that doesn't work, right? That's not a theorem. But we have right triangles, right? And we know that if it's ASS in a right triangle, that means it's HL. There's the hypotenuse right down the middle. And this is a leg. And of course, all HLs need a right angle. So this is HL. Okay, this is AAA, which seems very tempting, but there is no AAA theorem for congruency. So this is actually CBP. There's no sides given to be congruent, so we can't do anything about it. This one, it's SAS. It's right there. Two side pairs, one angle, the angle's in between. It is a right angle, and you might be tempted to do HL, but the hypotenuse, which is here, has no congruency marks. Okay, our freebie is the vertical angles, and that's AAS. Notice it's not ASA. If it was ASA, the angle, the side would be there. Don't write that. That's not right. That's where it would be if it was ASA, or it could be ASA. It could be both. But this is AAS, where the S is not between the two. Good little review there for that one. Okay, we got, again, I'll use their notation. So we've got congruent vertical angles. That's ASA. We've got the reflexive property here. That's SSS. This one, very tempting. It is reflexive property. And you'd love to say that these two angles here are right angles, right there and right there. But we have no information about that, right? They could be 89 degrees and 91. So this could be 89 degrees. We don't know. It looks pretty much the same if it was only 1 degree off. So we don't have any more information. So even though it probably is congruent, remember the idea is, can it be proven? And the answer is no, it can't be proven. Okay, so CBP. All right. This one, the freebie is reflexive property, so we get SSS. Now, what's weird is that these are the same, so you're tempted to think that's only one. Okay, but there are 3 pairs here, right? There are 3 pairs here. So this is one pair, this is another pair, and of course the shared side, which is this one. They share a side, so that's actually SSS. All right, this one is tough, and I'm glad we were going over this one because you guys struggle with this one a lot. Write the congruency statement. The congruency statement is not the theorem like we did up here. This is saying triangle whatever is congruent to triangle whatever. So the first triangle, always alphabetical, left to right, triangle ABC. Okay, and now we have to line things up so they match. So if you look at angle A, right, if you look at angle A has a single congruency mark. So R is the one that's corresponding. Not to be confused with corresponding angles, right? So R goes with A. See, R is in the first position, A is in the first position. Okay, B is the double congruency mark. So I'm looking for S to match it here. RS, and then the third one just follows suit, RST. Notice it's just coincidence that the second triangle is in alphabetical order. Doesn't have to be. It has to match with the congruencies. Okay, here, triangle ABC. First one is always alphabetical order. Congruent to. Now, if you haven't tried this one, I would pause the video, try it right now, and then see if you get it right. Okay, A lines up with J. B lines up with K. See, they're both double congruency marks. And C lines up with L. Okay, here, triangle ABC for the left one is congruent to. Well, what lines up with A? D, angle D. So D, and then B over here. Now look, careful. B is this angle in here, right in there. See, what is that going to line up with in the other triangle? Right there. So you got to be really careful, okay? We actually can't call that angle B, as you know. It's angle ABC. So, but the B in here lines up with the C in the second one. So it's D, C, B. It seems counterintuitive. You think the B's would go in the same position, but they don't, because there are two different angles at B. There's two non-congruent angles hanging out at B. So it's not B to B. It's B to C, and then C to B. Okay. Identify these. This is, of course, a right triangle because it has a 90-degree angle in it. This is obtuse because it has an angle greater than 90. This is acute. It's an equilateral triangle, of course. This is obtuse, greater than 90. This is right. That's a right isosceles triangle. You should remember that from the previous quiz. And this is acute. Okay, let's go to the next page. You don't have to know how to do this one. This one's equilateral. Okay, I think the question on this was what kind of triangle are they, right? So this is equilateral. But if I did ask you what the angles are in this problem, you should be able to tell me what these angles are. And they're all 60 degrees, of course. This one you don't need to know what to do. This one is equilateral. And again, the angles are all 60. This is isosceles. I may have spelled that wrong. Sorry, isosceles. And so is this one. Okay, same. Just save some time. Okay, over here. A lot of you struggle with these. You got to remember the two things. You got to remember that the angles add up to 180, and you've got to remember vertical angles, right? So when we take these angles, we add them up, subtract them from 180, we get 55. And that's that angle 1. And of course, angle 2 is the same. They're vertical angles. Okay? And then we have another 55-degree angle. That's 110. I think that leaves 70. I'm rushing, so if I get one of these numbers wrong, just follow the procedure. Use your calculator. Don't panic if I happen to just add wrong really quickly. It happens. You know the procedure. You know what you're doing. If the calculator tells you you're right, it's probably right. Okay. 55 and 70, that's 125. So what's left is 55, right? Which makes that isosceles. Now, that's not what they're asking for. They're asking for angle 1 here, correct? They're asking for angle 1. So angle 1, that's a linear pair with this 55. So that has to equal 125. Okay. And same thing here. That's 150. Then this is 30. 30 and 55 is 85. That leaves 95. Okay. Both angles are the same. You got to look for the congruency. So you know that that's 30. That's 60 total. Whatever's left, 120 from 180, of course. Same thing, Dad. So I'm not going to really worry about these. These all work the same way. This one exactly the way as it does up here. The main one is this. This one everybody struggled with. Right away, you got to add this 90-degree angle in there, right? Linear pairs. That's key. And there's actually 3 triangles in this picture. And what I did in class is I highlighted, of course, this triangle here, the big mama triangle, right? So that is a right angle there. You're saying, wait a minute, that's like some small angle. No, it's a right angle at angle B, right? At angle ABC, I should say, is a right angle. Okay, so it's 90. I'm talking about the yellow triangle. I'm ignoring the 2 baby triangles inside. 63 is right here. That's 63. And this is whatever's left over, right? So it's 27 degrees. Why? Because it has to add up to 180. Now, the same thing happens in this baby triangle. So watch as I highlight this baby triangle here. So this green baby triangle here also has a right angle, and it also has a 63. So this little angle 1 in here is also 27 degrees. Okay, it's a special rule we're going to learn about later. When you drop an altitude, this is called an altitude from the right angle in a right triangle, it will create 3 similar triangles. That means they all have the same angles, and their sides are proportional. So that's a unit coming up. And you guys know how to do the rest of these. I'm just going to leave them for you. They're all the same. A lot of people struggle with 30. So a vertex angle is the top angle of an isosceles triangle. So if we're drawing a picture of an isosceles triangle like this, the vertex is this angle. It's the angle that's not congruent to the other angle, right? Like necessarily anyway. So this is called the vertex angle. So the whole key to this problem is that E is the vertex. So for DEF, you have to put E up here. And then D and F can go in either place, doesn't matter which one. And then finally, when you add this stuff here, 4x plus 12, that's 4x plus 12 along this segment's length. And of course, 7x minus 9. And you set them equal to each other, right? These are two congruent sides, set them equal to each other. We did this in class, solve for x. If you're not sure you got the right answer, just plug it into both of these. You should get the same number. If you do, you know you did it right. Okay, in this case, this is an equilateral triangle. So you know that this equals that. You write an equation, you solve for x, you plug it in. And when you plug it into all three, you should get the same answer, right? So that's a very easy one to check. Okay, here we did these in class. I'm going to go real quick. 2x plus 3x plus 4x equals 180. You can solve for x. I think it's 9. This one a little confusing at first. They're both congruent to each other. So x equals 2x minus 6. A lot of you say, how can that be? How can a 2x and an x be equal? Well, it's not 2x. It's 2x minus 6. You solve this equation, you plug a number in, you'll see that it works. You plug it into both, and you'll see you get two congruent sides. This one has an x and a y in it, so you have to be really careful. You have to deal with the x's first. But these are both base angles of an isosceles triangle. See? So you know they're equal. So the first equation is 7x plus 5 equals 9x minus 13. We did this in class, so I'm not going to finish it. You get the answer for x, you plug it back in, and then you find this through triangle sum theorem, right? This angle plus 4y has to equal 180. We did this in class. It's out of scope of this. This is, but we did it anyway. You can solve for this. I'm not going to do it here. It's not on the test. Okay. Are they congruent? Write the triangle congruency. That's triangle something is congruent to triangle something, and then give the postulate. Okay. So these are congruent here. Let's do the congruency first. So we have vertical angles, of course. And we get ASA. You're tempted to say HL, but there is no information about the hypotenuse. In fact, there's only one side. You need two sides for HL. This is ASA. Right angles are always congruent to each other. So this is ASA. Okay, and we're going to do upper left. So we're going to do this in alphabetical order. So CDE, you got to be real careful here. CDE, always alphabetical for the first one. C lines up with A, so A goes first. D lines up with B because they both don't have congruency marks on them. And E lines up with itself, even though you can't call it angle E. There you go. Okay, reflexive property here. So this is yes. This is SSS. Left triangle in alphabetical order is ELO, Electric Light Orchestra. You can ask your parents about that. Band. And E is going to match up with E. This one's harder to tell because we're doing sides, right? But basically the way it works is EL, the first two letters, EL has a single congruency mark on it. So EV has a single congruency mark, so I know V is next. Okay, you can double check the rest too. So if I take a different color here, LO has a double congruency. That's the last two positions here. And OV have to be in the last two positions because they also have double congruency. All right, so it's real easy to check that too using that method. Okay. You have vertical angles, as we've talked about many, many times. No, that's the mistake everybody made in class. Those are not vertical angles, okay? They probably are congruent, but they're not vertical angles. Vertical angles are formed by what? An X, see, like this. So that big angle would be congruent to that big angle. So it's a trick problem, right? There's no vertical angles here. And there's no other information, really. You have a congruent angle and a congruent side. But this could meet somewhere else, for example, and there's no other information about these two. So we're stuck because we don't know that these are, see, if these are right angles, we're all set, but we don't know that. They look perpendicular, but we don't know it. So really, this is a CBP. Oh, I'm sorry. And see, I was rushing. I said this might happen. I forgot they did give us one other piece of information, so we are lucky. Okay, so T is the midpoint of W. I forgot about that. This is congruent to this. So there is an extra piece of information, but ASS doesn't prove anything, so guess what? I was right anyway, but for the wrong reasons. Okay, you don't need the rest of this is a CBP. Okay. This guy here, they share a side, and you've got parallel lines. Parallel lines mean that alternate to your angles are congruent. So we know that this angle here, whoops, that's not right. That's not an alternate to your angle. We know, let's see. This angle here is congruent to this angle here. And we know that this angle here, for example, is congruent to this angle here. But that's not going to help me with this picture. Okay, none of the alternate interior angles are going to help me because they don't belong to the same triangle. So you'd be tempted to write this one and this one, but those aren't alternate. They are alternate interior angles, but for these lines, say for these lines, not for the lines that they indicate as parallel. So actually, there's nothing we can do here, and this is CBP. Okay, IH bisects WIS. That means these two are congruent. We get a shared side here, ASA. That's down here. Okay, I'm not going to write the triangle congruence, so you can figure the rest of that out. This shares a side, and therefore it's ASA. This is a tough one, so I'm going to do this one. I'm going to do the left triangle, which is EGL. Okay, now E to G, E to G to L. Well, this angle matches this angle, you see? So you have to rotate these triangles to get them to line up. So if we start with E, we actually start with L for the other one, and then we go to U, and then we go to E. So that's a tough problem. That's tough to see. Okay, but they're rotated around. You can't fold it over to make it match. That's why these letters are in a strange position, or at least they seem to be. Okay, now this is a lot different because here we do have congruent angles right there and right there. Okay, and we also have congruent angles here from the other parallel lines, from these parallel lines. We have a congruent angle here and here. And then we have a shared side. So this is ASA. These also, there's no room here, I guess I cut it off. These also will be rotated around. So when you do the triangle congruency, be careful, it's not what you expect. This is the hardest problem on the sheet, in my opinion. It's very hard to see. You have this triangle here is congruent to this triangle here. And you see how they share that side there? That's my reflexive property. So that's a congruency. They already have a side here and here with a single congruency. And believe it or not, although it's hard to see, they have two baby angles that are congruent to two baby angles that are congruent. So together, through angle addition postulate, that big angle V, or really WVY, and VYZ are congruent. So this yellow triangle and the green triangle are congruent through SAS, or from the other triangle, SAS. So that's a toughie. Okay, I'll leave it to you to figure out the triangle congruency there. Here we get a third angle, that's vertical angles, but big deal, 3 angles and 3 angles do not prove triangles congruent. Okay, next sheet. Find the sum of the interior angles for an octagon. Well, an octagon is 8-sided, so there are 6 triangles, and 6 triangles have 180 degrees each. Okay, just throw that in your calculator. Find the measure of each interior angle of a regular isosagon. Okay, well, we haven't done this one, so I'm going to skip this one, but you know how to do this. You find the measure of each exterior first, right? Okay, but we'll do the hexagon one. It's kind of a similar thing. But we're going to find the sum of the exterior. The sum of the exterior doesn't matter what it is. It's always 360. So that one's just done. Make sure every problem you had like that, like on the last quiz, takes you 2 seconds. You write the answer and you're done. But here, right, this is the measure of each exterior angle. Of each exterior angle. Of course, it has to be regular to do a problem like this. And it's a dodecagon. That's a 12-sided figure. Well, we know from the things we just talked about a second ago, all of the exterior angles, all of them, not each, all add up to 360. And in the dodecagon is 12-sided. So we've got to divide 12 in to see how many there are. Okay. And of course it's 30. So 30 degrees for each exterior angle. What would that make each interior, by the way? 150, because the interior, right, each interior, they didn't ask us this, but they will, we will ask you tomorrow, is linear pair to each exterior. Okay? All right, I'm going to jump around a little bit because a lot of these are very, very similar, right? But we'll do this one. So let's find each interior angle of a regular pentagon. Okay, I'm not going to solve that. What am I going to do? I'm going to do what I did before. 5-sided figure. I'm going to find the exterior and then use the fact that they're linear pair with the interior. So each exterior, which is always easy, is 5 goes into 360, right? So 5 goes in 7 times, 35, and 10 is 2. So it's 72 degrees. That's not the answer to the problem. That's for each exterior. They want each interior. Well, they're just a linear pair. So for a linear pair, of course, we're going to get 108. Okay? All right. I'm going to skip a lot of these. We'll do number 10 really quick. Find the number of sides of a regular polygon if each exterior angle is 18. All right. Well, now we know the sum is 360, but now we know the measure of each. See? So we're going to divide 18 degrees into 360 degrees, and we find out that we get 20. So that's a 20-sided figure. It's just the kind of the reverse of what we did up here. Here we knew the number of sides. Here we had to find the number of sides. Okay. The rest are very similar. We've done a lot of these in class, so I'm not going to go over all these. We did a lot of these in the other worksheet. Just look at your old worksheet or your old test on this, or quiz on this, and you'll get some more. Okay, I know one of my sections did this problem, one didn't, so I'm going to do it really quickly. The name of this figure, of course, is an octagon. It's 8-sided. Do you think it's a regular polygon? It looks like it might be. It doesn't matter what you write here. We'll see. We'll come back and figure it out. The length, not the slope in this case, the length. Okay, length. This is 2. If you have horizontal or vertical lines, guys, it's just counting boxes. CD is also 2. Right? FE is also 2. HG is also 2. Okay? Now, the remaining ones are diagonal lines. How do you find the slope of, well, you can use the distance formula, not slope, the distance, I'm sorry. The length. You can find the distance formula and do this. It works out perfectly. But I always said to you, remember, just travel from B to C, go horizontally. I'll use dotted lines to help us. Go horizontally. Oh, it's not really that dotted. Let's try a better one. I have to go 2 horizontally and then 2 vertically, right? That's a right triangle. That's a right triangle with a hypotenuse of the green, see? So the hypotenuse equals what? 2 squared plus 2 squared, a squared plus b squared, okay? In the distance formula, this is your x2 minus x1, and this is your y2 minus y1 if you want to use the distance formula, and of course this d equals the square root of. All I did was square both sides, but it's really just Pythagorean theorem. So to find the length of a diagonal line, just do the Pythagorean theorem, where this is the horizontal distance, right, from there to there, and this is the vertical distance from there to there. So c squared equals 4 plus 4, c squared equals 8, c equals the square root of 8, but remember that the square root of 8 is equal to the square root of 4 times the square root of 2, which is 2 radical 2. You don't have to have it in this nice, neat form, but I'm going to do it. Now, what you're going to notice is that all of the other diagonals are all the same if you try them out. So really, we're done. And of course, the answer is no, because these numbers are not all the same. It looks regular. It's not. Okay, same thing again here. AB. How far is it from AB? Well, if I go up 2, that's 2. So c squared equals 2 squared. And then I go across 4. That's plus 4 squared. C squared equals 4 plus 16. C squared equals 20. C equals the square root of 20, which is equal to the square root of 4 times the square root of 5, which is equal to 2 radical 5. We did this in class, both sections, so I'm not going to really spend a lot of time on this. 2 radical 5. It turns out that these both are 5 radical 2 by using the same method on the longer segments, so it turns out to be isosceles. Okay? And I'm only going to ask you, I'm not really going to ask you about obtuse and acute too often, mostly just right or not. To determine if it's a right triangle, you have to find the slopes. Okay, when you find these 3 slopes using rise over run, you'll find that none of them are negative reciprocals, right? If it's a right triangle, it would be perpendicular, and perpendicular means negative reciprocal slopes. None of these slopes are negative reciprocals. That's an Algebra 1 topic. If you need to review it, do it. It was on the last quiz, or 2 quizzes ago too. All right. I think that's it. All right, let's go to the next problem. This is an isosceles triangle. They're both 10, so that means both of these angles are the same. That makes them both 55. That's 110. That makes this 70. Pretty easy. This is a right triangle with 2 congruent sides. This is right from your other quiz. So you have two numbers plus the 90 that has to add up to 180. All right, you can do the math, but in 3 seconds, hopefully you can see that's 45, right? It's very, very common. We're going to use in this triangle a lot. 45, 45, 90 triangle, right from your other quiz. You do not have to know how to do this one, and you do know how to do this one. This one's X. x plus 64 equals 180. How do I know this is x? Because these are congruent. ITT tells me that these are congruent angles. So x plus 64 equals 180. In the figure above, if triangle XPW, that's this big giant triangle, is isosceles, what do you know? Well, if that triangle is isosceles, then I know that this angle is congruent to this angle. And they also told me that XP, oh, well, actually, that's XP is congruent to WP. We already knew that because they said it was isosceles, okay? Name two congruent angles, so there they are. Angle X and angle W. Okay, I think this is the final page. Name two congruent angles. So all you got to do is realize that PY is congruent to PZ, right? That makes it isosceles. Name two congruent angles. So it would be angle Y and angle Z. Okay, it's the angles opposite the congruent sides. Okay. If XPW is a right triangle with a right angle, what is the measure of angle X? So if XPW, right? So XPW is the right angle. What is the measure of angle X? You don't know. I don't know if it says it's isosceles. It might have. I believe it should have. So they probably meant to say this is isosceles right triangle, which would make these both 45. They didn't, so it's really not solvable, or else I'm just missing the instructions here, possibly. Okay, that's it. I hope that was helpful for you guys. Again, 90% of the problems were solved. The rest you can solve yourselves, check your answers, and we did a lot of them in class. So that should be plenty for you to review. Don't forget to review your old tests and quizzes, and of course, worksheets. You have all the solutions for those. Best of luck tomorrow, guys.